Thus, the steric number of nitrogen in NH3 according to its Lewis dot structure, which is given here, is 3 plus 1 equal to 4. Similarly, for sulfur in SO2, whose structure is, the steric number will be 2 plus 1 equal to 3. For xenon in xenon difluoride, with the structure given here, the steric number of xenon will be 2 plus 3 equal to 5, and so on. Steric numbers are generally calculated for the central atom of the molecule because that decides the geometry of the molecule. Steric number is related to hybridization in the following manner. For steric number 2, hybridization is sp. For 3, it is sp2. For 4, sp3. 5, sp3d. 6, sp3d2. 7, sp3d3. Now we shall discuss the individual steric number and the corresponding hybridization. So we begin with sp hybridization, steric number 2. Geometry will be linear, shape will also be linear, and standard bond angle will be 180 degrees. Some examples are given below with their structures in front of the example. So first is BeF2. Next is CO2, carbon monoxide, C2H2, CH2 known as triplet carbene, N2, N3 minus known as azide ion. It has a polar structure. The central nitrogen is in the sp hybridization state. NO2 plus known as nitronium ion. Then there are some miscellaneous examples. Si-S3NCO known as silyl isocyanate, and CH3CN called ethane nitrile or simply methyl cyanide. sp2 hybridization, steric number 3. In this, as discussed earlier in Vesper model, following two types of cases are available. Number 1, AB3. Number 2, AB2L. In case of AB3, geometry will be triangular planar, and the same will be true for AB2L. But as regards shape, AB3 will have triangular planar because there is no lone pair. But AB2L will have V shape. Ideal bond angle is 120 degree in AB3. But bond angle in AB2L is definitely less than 120 degree due to the presence of lone pair. So some examples of AB3 type in which A is the central atom, which is sp2 hybridized, are given below. Against each example, its structure or bond structure is given. So, first example is C2H4, ethene, where both of its carbon atoms are in sp2 hybridization state. Next is C6H6, also known as benzene. Here, every carbon is in the sp2 hybridization state. Carbonate ion CO3 2-. Only one carbon is there, its steric number is 3 and it is in the sp2 hybridization state. Well, next example is graphite. It is an allotrope of carbon in which each carbon atom is sp2 hybridized. A detailed study of the structure of graphite will be done in fourth group of P block later on. Next is BF3, a very simple example. SO3, known as sulfur trioxide. And finally, NO3-, that is nitrate ion, whose structure is given here. In fact, in all the oxyacids of nitrogen that we shall study later on, you will find that all nitrogen atoms are in sp2 hybridization state. Then we come to some examples of Ab2L type, which are given below, and all of them have V shape. The first example is CH2, that is singlet carbene, sulfur dioxide, stannous chloride SnCl2, nitrosyl chloride NOCl. Remember, in NOCl, it is the nitrogen that is the central atom. Next example is ozone. And finally, nitrite ion NO2-. Then we have some miscellaneous examples which are in this category: B3N3H6, that is known as inorganic benzene or borazine. SiS3 trisilyl amine, CH3CONH2 acetamide, H3BO3 boric acid, CH3NCO methyl isocyanate, N3H hydroazoic acid, FNO3 fluorine nitrate, and ClO2 known as chlorine dioxide.